Alright guys, so today we're looking at how we use the inverse properties of logs and how we find inverse functions of logs. So first we're going to figure out what the inverse properties of logs are. And we're going to do that by taking these things that have to be true. B to the x must equal b to the x. And log base b of x must equal log base b of x. And we're going to use that loop to figure out what the inverse properties of the logs are. Okay? So if I were to loop this, it's starting as an exponential. Whenever you use the loop on an exponential, it'll end as a log, right? And if you start with a log, it ends as an exponential. All right, that's going to come back to play at the end of the notes today. So it doesn't really matter which side I do the loop with because they're both a base of an exponent. So I'll start with this b because it's a base. Go around the equal sign. Let me do that in a different color. So start with the base, go around the equal sign, and end up at this x. So now this says, remember exponential turns into a log, that the log base of what? What did I start my loop with?
B.
With that b. So log base b of, what was on the other side of the equal sign? B to the x, right? So log base b of b to the x equals what?
X.
Equals x. Okay, I just made things a little wider. Let's rewrite this one over here. Here's my base of the log, so I'm going to start with that in my loop. Go around the equal sign, end up over here. Okay, now, it started as a log. What should it end as?
Exponential.
An exponential. So what's the base of the exponential? B. So we have b raised to the all of this. So b raised to the log base b of x equals x. All right, so these two things these are the inverse properties of logs. Just so we can understand like these b's and x's a little bit better, we're going to look at this example. So you guys should be able to tell me log base 2 of 8, what does that equal?
3.
It equals 3. Why does it equal 3? Because 2 to the third power equals 8. Okay. Now, would I be changing anything if I said, okay, that's log base 2 of, I could rewrite 8 as 2 cubed. Right? So 2 cubed is still 8. So this should still equal 3. Okay, from that, what if I said log base 2 of 2 to the x? Using that previous example, what should this equal?
3.
So the only thing that I've changed is this 3 to an x. So what should change as far as what it equals? It should equal x. So as long as these two numbers are the same, the base of the log and the base of the exponent, then the answer would just be whatever this base is being raised to. So that's where we get log base b of b to the x equals x. Now I realize that's only half of it, but that's why if you have like this b to the log base b of x equals x, that's why we could say, okay, 2 to the log base 2 of x, well, let's not even do it with x right now. Let's say
3.
of 3 equals 3. Okay, like as long as these two things are the same, it's whatever you're taking the log of. Just like a moment ago, whenever we did that loop, this would be log base 2 of 3 equals log base 2 of 3. So 2 to the log base 2 of x must equal x. Alright, so let's do some examples. Alright, so we have the properties listed up here. Log base 3 of 3 to the x. And I'm just trying to simplify that. Trying to say, what is this the same thing as? Well, this looks a lot like this, doesn't it? If you were to replace these b's with 3's. So if log base b of b to the x equals x, what do you think log base 3 of 3 to the x equals? That's right. In b, we have log of 10 to the 2x. Alright, again, this is looking a lot like this first one. The only thing is we don't have that real small number, right? We don't have log base anything. If it's just a log with no number, what is the base that's hidden in there?
10.
For log, it's 10. And what kind of log is this called? Common log. A common log is a log base 10. So I have log base 10 of 10 to the 2x. The 10's match up. So what is this 2x? Or I'm sorry, what does this all simplify to? 2x. So in these first two examples, we just want the base of the log and the base of the exponent to be the same, right? 3 and 3, 10 and 10. And then we can just look at the exponent. The problem here is that the base of the log and the base of the exponent aren't the same. So in this case, we have to make them the same. Okay? This 2 can't really change, it's the 2. Could I write 16 as a 2 to the power of something? Yeah, 16 is the same thing as 2 to the power of 4. So I can rewrite this as log base 2 of 2 to the 4th to the x. So none of the numbers have actually changed. We just changed the way that we represented those numbers, right? 2 to the 4th is 16, so I haven't really changed anything. Now by our properties, 2 to the 4th to the x, if you have a power to a power, what do you do to those? Yeah, you multiply. So that's log base 2 of 2 to the 4x. So what would this simplify down to? 4x. Because now that those 2's are the same, we just look at the exponent. Down here in the bottom we have 5 to the log base 5 of 3x. So as long as their bases are the same, the base of the exponential and then the base of the log, what does this simplify down to?
3x.
Yeah, just whatever they're taking the log of. Again, 10 to the log of x, you don't see the base, but the base is there. What's the hidden base right here? 10. So the bases are the same. Right. So since the bases are the same, what does this simplify down to? Just that x, just whatever's left over. On this last one, we have e to the natural log of 7x. So a natural log, I could rewrite this as e to the log base e of 7x. Remember that log base e we represent with ln, natural log. So these both have the natural base. This simplifies to 7x. So again, just another way to quickly look at things. If back at example A. If this x was a 2, whenever you're trying to simplify this, you'd think 3 to what power equals 3 to the second power? Well, that'd have to be a 2. So 3 to what power equals 3 to the x? It still has to be an x. This, like, equals something hidden. Anyways, whatever. We're moving on. With or without you. But hopefully you're with us. I love you. Okay, so now we're going to focus on finding the inverse functions algebraically. Just like any finding an inverse, you start by swapping x and y. Okay? Then to be able to do the loop, we'll talk about like all the rules of that later. But for these first, we'll just loop, and then you just solve for y. Now, the biggest note that I want to make is that if you start with a log and you're finding the inverse function will be an exponential. So if you start with an exponential, the inverse will be a log. So we're starting with a log. Will my answer have log in it? No. Okay, so I start by swapping x and y. Log base 3 over 2 of y equals x. Okay, the log is by itself. That's the next step, is the log by itself. So yeah, so I'm ready to do the loop. What's the base of the log? 3/2. So go around the equal sign. So the loop turns it from a log into an exponential. So this is, the base of the log was 3/2, so the base of my exponential would be 3/2 raised to what power? Raised to the x equals y. That's already solved for y, so that's the inverse function. That means that if you were to graph this and graph this, they would be reflected across the line y equals x. Okay, so let's try that again. Swap x and y. Log base 7 of y equals x. Start with the base, go around the equal sign. 7 to the x equals y. And that's the inverse function. Okay, so we're looking at y equals the natural log of x minus 4. So my first step is to swap x and y. X equals, I'm going to change the natural log. I want to write this as a log. So natural log is log base what? Log base e of y minus 4. So I swapped x and y and I changed that to a log base e. Now, I'll do my loop. Look at that, the loop went backwards this time. But it's okay, as long as you start with the base of the log, go around the equal sign, and end up over here. I have e to the x equals y minus 4. Now, what's different about this time? Yeah, there's a 4 over there. Am I done, or what should I do? I should add 4 to both sides. E to the x plus 4. Notice that that plus 4 is not in the exponent. Equals y. In example D, we're starting with an exponential. Okay? Starting with an exponential, what should my answer look like? A log. So it's really good to have that in the back of your head before you even start the problems, okay? So I start by swapping x and y. X equals 7 to the y. Now, we have to remember how to do the loop on an exponential. Where's my loop going to start?
7.
At the 7. Why at the 7? Because it's the base of the exponent. So 7 around the equal sign. Now, we know it's a log, so it's log base 7 of what?
Y.
Of x equals y. All right. This is another exponential, so what's it going to end as? A log. So I swap x and y. X equals 3 to the y minus 4. Okay, here we run into another problem.
You add 4 to x before you.
The log or the exponential must be alone before you can loop. So here I have an exponential 3 to the y, but it's not alone. It's got a minus 4. So before I can loop, I need to add 4 to both sides. So x plus 4 equals 3 to the y. Now I can loop. Start with the base of the exponent, go around the equal sign. And I have log base 3. Now notice that we're taking the log of all of this x plus 4. So I'm going to put this in parentheses. Of x plus 4 equals y. Okay, let's try that one more time. I swap x and y. X equals 4 plus log of x. Let's go ahead and write the base. What's the base if it just says log of x? 10. This is a common log. The log is not by itself. It's got this 4 hanging out, so I'm going to subtract 4. Oh, sorry. That should have been a y. So, the x isn't by the log isn't by itself. Let's subtract 4 from both sides. Log base 10 of y. It's a log right now. What is this going to end as? An exponential. What's the base of my exponential?
10.
This 10. Because it's the base of the log, right? The bases stay as bases. So I have 10 raised to the x minus 4. So everything's in the exponent this time, unlike example C, equals y. And that's how we find the inverses. Okay, bye.